Going on to this question, part 2, it says prove that the points L, M, and R are collinear. So what we need to do, we need to revise what it means for points to be collinear. What does that mean in mathematics? So let's do a little research on some information that we've got stored. Here's a document that was prepared which talks about proving parallel and collinear. What does it mean to be parallel? Proving parallel. The earliest definition we learn of parallel lines is that they travel together in the same direction and never meet. This definition is useful. Another definition says that parallel lines have the same gradient, a principle you learn in coordinate geometry. Combination these two definitions, we can formulate a suitable definition of what it means for two vectors to be parallel. When it comes to vectors, if we are to prove that the two vectors are parallel, it is necessary to show that both vectors have the same direction. One way of doing that is by calculating the angle. Tan inverse of y over x, that is, we could just find the angle for both vectors and show that they are the same number. Therefore, that is one way to prove parallel. They have the same gradient, they have the same angle, so therefore they are parallel. However, alternatively, it is enough to show that one vector is a multiple of the other. And how do you do that? Oh, here's the diagram there. So that's for, we'll come to that diagram. Given vector AB, for example, to show that AB is parallel to another vector CD, we only need to show that CD is a multiple of AB. There is a number you can multiply to AB to get back CD. Okay? Where K is a real number. So let's say you have example AB is 3,1 and CD is 6,2. CD is bigger than AB. So if you can get a number outside of a bracket and when you multiply, you get back CD. Therefore, CD is a multiple of AB and therefore they are parallel. And that number is 2. If we put 2 outside of AB, we multiply AB by 2 because remember AB is 3,1. 2 3s are 6, 2 1s are 2. Therefore, CD is indeed a multiple of AB, and that they are therefore parallel to each other. Another way to write vectors is in algebraic form notation. Let's say you have AB is equal to 2x minus y, and CD is equal to 6x minus 3y. Now, CD is clearly bigger than AB again. Now, if we can put AB in a bracket and put a number outside, that's the multiple number that you have to multiply by, to get back CD, therefore they are parallel, and that number is 3. 3 to the 6, 3 times -1 is -3, thus showing that it is a multiple and is therefore parallel. Now we move on now to collinear. Proving collinear points. Points. The word collinear simply means to be on the same straight line. So these points have to be on the same straight line. To prove that 3 points are collinear, we need to do 2 things. Show that one vector is a multiple of the other. So therefore, we need vectors. We need 2 vectors to show that one is a multiple of the other, meaning that they are parallel. And 2, to show that they have a point in common, that is, the vector names have a common letter. So the points are named by letters. I think 2 should come first. I think we should get those 2 vectors first. Make sure that they have a point in common. That means the letter is repeating, and then to show that they are multiple of each other. So let us apply that now to our situation. We are to prove that L, M, and R are collinear. L, M, and R are points. We have to show that they are on the same straight line. Let us go to the diagram and get that same straight line. Here is L, here is M, and here is R. Can we get a straight line that they are on the same, they're on that straight line? Yes, here it is. L, M, and R are points on a straight line. So let us prove that really and truly that they are collinear. So let us get two vectors. First thing, let us get two vectors, first and foremost. Just by looking at this, we can get a vector LM. So that's number one, the two vectors. LM and LR. As you can see, LM and LR, here it is LM and LR, they have a point in common, which is L. So our first, we are halfway there already in our proof. So what we need to do now is to show that they are parallel. Parallelity, you want to put it that way. So that's the two vectors, and we have to show that they are parallel. So first, let us find vector LM. LM, we have already found LM. LM is minus a half U plus a half V. LM. Now let's find LR now. To go from L to R, you have to do an LO plus an OQ plus a QR. So LR is equal to LO plus OQ plus OR. No, let us write this in terms of U's and V's. LO is opposite to OL. The symbol to translate the word opposite in in vectors is the negative sign. So LO is opposite to OL. So LO is minus OL. And we have OQ plus OR. Now let's translate in terms of U's and V's. OL is 2U. There it is. O to L is 2U. So that's a minus 2U. OQ is V. And since Q is the midpoint of OR, QR is also, oh, that's also be QR. That's what QR is. OQ plus QR. QR now is another V because Q is the midpoint of OR. So that's a V and another V right there. You can even write it. Yeah, that's another V. OR is another V. So therefore, we can replace QR with the letter V. And as you can see, LR simplifies to minus 2U plus 2V. Clearly, LR is longer than LM. So let us prove that LR is a multiple of LM. To do that, we introduce brackets. We place LM in the bracket, or parenthesis like the Americans say, and we try to get a number such that when we multiply, we're going to get back LR. If we try 1, multiplying 1 by minus a half and a half will not give us minus 2 and 2. Let's try 2. Multiplying 2 by minus a half, that's minus 1. 2 by a half, that's 1. 2 will not go. Let's try 3. 3 by minus a half, you just have minus 3 over 2 and 3 over 2. Remember, it's a minus 2 and a 2 we want. So 3 cannot go. Let's try 4. 4 times minus a half will give us minus 2 because half of 4 is 2. 4 times a half will give us 2. Half of 4 is 2. So therefore LR is a multiple of LM. So we have proof parallelity. And the two vectors have a letter in common. So therefore, the points are collinear. Since the vectors is bigger, since the vectors LM and LR have the point L in common, and LR is a multiple of LM, meaning that they are parallel. Therefore, L, M, and R is that the points are collinear. Okay, please don't confuse. Vectors are not collinear. It's points that are collinear. Okay, vectors can be parallel or have points in common. Okay, so the points L, M, and R are collinear, meaning they fall on the same line. You can find them on the same line.